Yeah, hello everyone. Today we are building a Spiderweb generator together. We are starting by building a simple version, and afterwards I will show you the advanced version, how it works. And of course you can download then the files on Gumroad. And first I like to start with some theory to show you how we start to build it. So I think we can start. So this here will be the setup that we built here. That's the simple version, and this one is the advanced one. You can see here the simple version, we have some settings. So first we can use a center point here, this null, or without the center point. So you can move the center point around. And then the setting how much loops the web has and where it starts and where it ends. And then we also build kind of a random parameter that randomizes the spiral webbing here around. So, okay, here's some explanations first. So first we need an initial setup before we dive into nodes. We need some start points here. We build those start points with spline. And then we need a center point. This will be a null object. And then we starting with the node setup. So we building a single thread first. So we get one start point and the center point. We build a vector from the start point to the center point, then divide it by a defined count here, and then feed the vectors here inside an array. So this will be our single, I call it here string array. So this will be a single thread. Then the third step will be we repeat this step for every single start point. So for this example here, we have then 5 threads, and those 5 threads go into one big array. Call this here a thread collection. And at the end, we are building our spiral connections here. So we go from thread to thread and building kind of a spiral spline here to the center, and this will be the last step. And yeah, I think that's it for the explanation. So now we can start with the setup. Okay, what we need first is a spline, so our start points. So let's build a spline. Let's make it here from the top view. Just keep it simple. We draw some points here, like this. Then we need a null object. Maybe make this as a circle. And then, because our spiderweb will be a spline object, we are building a spline capsule. In Cinema 2024 is called now, you can type in node, and here you see there's the node mesh and the node spline. That's what we need. Then let's jump inside of the capsule, double click the node spline, maybe put this down here. I don't need this one and this one here, so we have some space for the nodes. So, and then what we need first is we want our spline as a child. The null we put also in here. So we first use a child operator, then op as a new input, children also as a new input, then go to edit resources. You will see here the menu is also new here in 2024. So then click on children, then go to advanced, and the scene port mode has to be object. So now we have our children's here. So we need the spline first. Here the spline, we like to have the points. So we can use a geometry property get. Then plug geometry here, and then the type will be point position. So now we have here an array with all the spline positions here. Next, we like to have our null object. So we drag it in here. So it comes here as a classic object. So, and we want the object part as an input. So add a new input. So when we go to the node here, to the capsule, you see here, we have now an object where we can switch our center point. Let's call this center point. So let's start by building our first single thread as explained here, this one. So what we need first is a range node to decide how much pointers our single thread has. So we use a range for this. Range, and then here the end we can maybe say 5. We want 5 points. Then make this also as an input. Let's call this loop count. And then next, what we need is here our start point. So we start first with just one. So we use a get element. So plug this in here, and the index is 0. So this is our first point. And next, we need a vector here from our start point to our end point here, to our center point. So we can do this with a subtract node. Simple, just 2 vectors, subtract one vector with the other. So we use here the position of our null object and subtract the first point here of our spline object. And now we have here, we have the vector from the start point to the center point. And next we like to scale this vector here by here those numbers. So by the range we defined. So let's use a scale node for this. So here is the scale, and we want to scale a vector. And here we can scale the vector. For this, we have to divide the range with our count. But first, we have to subtract 1 from our count. It is an integer, subtract 1. And then we use divide. Float is okay. So then the range, we divide the range with here our count. And now we have, here we have our loop count is 5. So now we have 5 points. So we have now those numbers from 0 to 1. And this one we can use here inside of the scale. So we have the vector here is now scaled by 0.2, by 0.4, and so on. And this gives us the intermediate points here. And now we have to add those vectors, those intermediate vectors with our initial start point vector. So use again an add vector. Then this with the scale here. And now we want to collect those vectors inside of an array. Because we have here an iteration with the range, like an iteration that runs 5 times, we can collect this iteration here with an assembly collection. So then we have to decide what it is, what kind of collection. So it is an array. This is on the structure array. Then inside the array, at the moment there is float values, but we want vectors inside, so our position vectors. So replace this with vectors and then feed them inside here. And what we can do now is to close the iteration here. This is just for visualization, but what we have here now is our single thread. So new in 2024, we can group this with scaffolds. So press Ctrl G and call this single thread calculation, for example. Oops. And to check this, we can use an assembly spline. Feed our points from the single thread inside the assembly spline and this to the geometry. And now we can see here we have our first connection, and when we convert this to an object here, you can see it has 1, 2, 3, 4, 5 points. Okay, delete this. And now we want this for every start point. So for every start point here of our spline. So that's pretty simple. So we just have to replace this get element with an iterate collection. So we use an iterate collection. So and this iterates over all our spline points here. And now we have here the element. These are all our individual points. And now replace here this one, the get element, with the elements here. We can delete now the get element. Now we have here 5 points, and now we have 5 different arrays. So we have to collect those arrays inside of the big array, like this one here, as I explained. So use another assembly collection. So the collection is also an array, and inside of the array is another array. So like the single thread array, structure array, and in this, as explained before, there are vectors inside. So we can feed those inside here and also close the iteration here with those 2 curly brackets. And then just for good visualization, also a scaffolding, call this all threads. Maybe give this another color here so we see it a bit better. Something like this. Yeah, that looks good. Now to check if everything worked, we have to first put all points here inside our threads here all in one array. So that's pretty easy. Use another iterate collection. And then you can see here are the arrays, so our 5 arrays for every thread. And we have also to iterate over them. Iterate collection again. And now here are the single points. And those points you have to collect in a final array. So we can use an append node for this, append elements. Here we also can say what type it is, what type of an array. So here again, it's an array with vectors inside. Vectors. Then the elements inside here, the value. And now this append element here that collects all the vectors. Now we feed this inside the assembly spline. Here I made a little mistake. I forgot here to feed our vectors inside the subtract here. And now you can see we have all our threads. So maybe we can move our point around here, center point, and you can see we have all our threads. So, but we have a problem now. Maybe when we convert it here, it looks correct. So, but let's make it a bit bigger. When we get a point here, move it around, you can see there is, maybe hide this, you can see there is a connection that we don't want. So that's because we are here, we collect all the points. So we start here from the point 1 and go into the center, and then we go up here to this one, and that's this connection. So we don't want this connection here. So we have to decide here in the assembly spline also our segments. For the segments, we need our own array with integers inside. So we can build this with a fill array. So, and we need the fill value. First, the data type is integers. So we need the fill value and the length. And the length, because we have 1, 2, 3, maybe delete this. So this one you have 1, 2, 3, 4, 5 here, 6 threads. So the fill value, the length has to be 6. So we can use here this iterate collection here. So where we iterate over all our threads, use the count here as length. And the fill value is here our input, the loop count, and this here into the segment. Now we can check again. Maybe hide it. And now you can see we have here single segments. Oops. Yeah. And you can see these are single segments. So now we can start to build our spiral. So this one. So for this we need another range. So we want to decide where to start and where to end. So let's make a range. Maybe like a bit smaller here. And now here we can say, okay, we start by 0. This will be outside here, and the end 5 is the center point. So, but here maybe say start by 1 and end by 3 for this example. Then we have to the range. We have to iterate over our threads here. So for every range, we have for the first loop, when we say these are loops, go around. So we need for every loop, we need every thread. So we use another iterate collection here. And then put the curly bracket here into the iterate collection. So now we have for every range here, we have now here every thread. Then we need the corresponding point to this range. So we can use a get element. Go into the single threads and get the corresponding point. So for the first iteration here, the one, it will be around here and then it goes around. When it's finished, it goes to the second. So to the second iteration here, and this builds our spiral. Next, we like to collect all those vectors inside of an array. So we can do this also here with an append element. So maybe copy this, put this inside here, and now it fills this array with all the vectors. So we can check this now here. Maybe remove the segments, feed this in here, and now we can see we have a spiral here. Now we can go like 4, or from the outside. Now here we can decide, oops, now here we can decide how much spirals we like. Now we have to combine this here, the spiral array, and here our thread array. We can do this with concatenate to combine those arrays. Here first array and the second array. Then this inside the points. Here just one. And now also the segments, because our spiral is just one segment, we can add here to the fill array, we can just append an element, append just one element, and the value is of course the count here of all the points of our spiral array. So let's use an get count inside here, and then back to the segments. And now this is our final spider web. Now let's organize it a bit. Maybe let's call them spiral red. Oops. Okay. Now we have to, because here when we go higher than our initial loop count, you can see there's something goes wrong. It jumps back to the outside. So we have to clamp this value here. So we can use a clamp. So we like to clamp is our here the input. Let's call this loop end, and we want to clamp it by the loop count, and then this goes here into the end, and then the start also as a new input. Call them loop start. Now let's fill in some values. So the loop count, maybe 15, loop end to 13, and this here to, and now when we go higher than 15, so it stops here. So this can't go higher than the loop count. And now we have here our center point here to move the center around, but we also like to have a center point that is calculated when we don't have here when we don't have a null object. So when we clear this, it goes into the center of the node of the capsule. So when we move a point around here, maybe like this, it will stay here in the center of our capsule, but we want the point inside. We want in the center of all our points. So let's go back to the start. So that's not too complicated. We can use an average for this. It's called arithmetic average. So, and the average will be vector, and we can feed in all our start points here, and this will be the average, so the center of all those points. And now we like to switch between our null object and between this average. So we can use an if statement or an if node for this. And then the type will be vectors here. So let's the condition. We make an input and call this, for example, use null object. And if this is true here, we use our null object. If it isn't true, we use here our average and then plug this to here. And now you can see, let's go here to our node. So when we click the feed in here our null object, when you say use null object, we can use our null object to decide here. Oh, I made a mistake here. We don't want this position, so we want the local position here. You can see we have here an offset between our null object, here our null object and the center. So that's because I think that this position here is the global matrix. Let's check this. Yes, we want the local matrix. So here local matrix. And now we can move here our null around. And then when we check this here, how it calculates here the average center of our spider web. So yeah, and now rearrange, we like to rearrange here our parameters. So let's go to edit resources. And I like to show you a little trick. Maybe move the use null object here above the object. And now we can decide if this parameter is visible or not by checking and unchecking here our checkbox. So that's pretty easy. So first we go to our checkbox parameter, copy the name here, then go to here our object. Maybe let's call this also null object. Then go to advanced, and here we have a show condition. So let's make two curly brackets. Inside of those curly brackets, we use the name here of our checkbox. And we can say here, if this checkbox is equal to true, if this is true, just write true. Whoops, here, true. Okay, and now when we check here, it shows, and when we uncheck, it hides the parameter. You can see here it resets our values when we adjust here our resources, so maybe adjust them too. So go here to the loop count, to general, say the default value maybe is around 20. Then we can build a slider for this. So slider limit, maybe from minimum 2 and maximum maybe like 50. Then also go to the value limits and say the minimum is 2. And here we go. For the last part, you can see this is not super interesting. We like to have some kind of randomness on the distribution of our spiral. So we have to, here where we build those values here, we want to randomize those. So we can do this with a hash node. Then the seed, here is our loop count, our range here, seed, and then the salt is here our threads. Here are the count of our threads. So we use the index inside of the salt. And then the minimum and maximum value we like to decide here with also a parameter. So the maximum to here, and the minimum should be the opposite here of the maximum. So use a negate for this. So when the maximum is 1, here the negate will give us -1. So it goes in plus and minus direction. And then we like to make this a bit smaller. Use a multiply here, feed in this to the multiply, maybe just 0.1, and then this here into those, into the minimum and maximum. Then we can add here our random float with here our, where we calculate our scale here, and use an add. Then when we go here, maybe see when we go to 1, it is way too high. So let's also call this random. Also adjust the parameter here. Maybe also make it as a slider, and then the minimum maximum will be 1. Default value maybe 0.1, and then the step super small. And now we can here, you can see we can add some randomness, but there is a problem because when we zoom in, it also randomizes here the center, and it also randomizes here the outside. So that's not what we want. They have to stay fixed. So we can fix this with a spline mapper. Use a spline mapper. Then we feed in here our values from 0 to 1. And then we map them here. So we get a value here from 0 up to 0.5 and back to 0. And then we multiply our random value here with the spline mapper, and then add this here to the add node. And now let's check. So yeah, now you can see the center stays fixed, and also here the start points. Okay, now let's organize it a bit. Oops, this one goes in here. And then this here is our random function. And that's it for our final setup. And next I like to show you the advanced setup. Okay, here you can see the advanced setup. Yeah, and if you're interested, you can dive here into the setup here and have a look how it works. So first here, the settings here are pretty much the same. Here the first one, so we can use a null object here. Oops, not this one here, to decide where the center is. And Then here also the loop count start, and then I have a parameter for the holes, how much holes are inside of the web with a seed value. And then here is also the random setting. That's the same that we did in our simple node setup here with some seed. Then also beside the random setup, there is a noise setup. So you also can use noise to randomize it. And here is the noise influence. So here we can decide where the noise should be. Also here is the same. We don't want noise here at the end, at the start and at the end. So that's this setting here. So you see when we go up here, it also applies here into the center. So then we have gravity. Oops, here the gravity is, we have gravity for a single thread here, for the spiral threads. So you can see here they go up and down here, and then we have here a gravity for the whole spider web. And here you also can say if we like that the center point here should stay where it is. Can go here also to 0. Then something like this. Yeah, and now it fits here. It don't fits because here our last setting is the wind. We also have can apply some wind. So when we press play here, you can see there is just a noise field that goes through those threads. And now here's the same principle. If we don't want wind here at the center, just put this down, then here up, and now the center stays still. And then of course, if we like to paint a new one, we can go to the endpoints here, delete all the points, and then start to draw some new threads here. And if we like to paint a spider web to an object, maybe let's use a sphere here, then just activate snapping, then go here to polygon snapping, again go all the points, delete all points, and then we can start here to draw a spider web onto the sphere. So yeah, that's it. As always, you can download the files on Gumroad. You find this in the descriptions. And if you have any questions, let me know in the comments. Bye bye.